In this video, I want to cover how we know if a chemical equation is balanced. So the first thing that we're going to put into our notes is balanced chemical equations. Balanced chemical equations indicate the process that takes place during an actual chemical reaction. Until an equation is balanced, it is not indicating the actual process. In a balanced chemical equation, the number of atoms of each element are equal on the reactant side and product side of the chemical equation. So the number of atoms, not just the number of atoms, but the number of atoms of each element are equal on the reactant and product side of the chemical equation. So our job when seeing a chemical equation is to make sure that it indicates the actual process taking place in real life by making sure the number of atoms of each element are equal on the reactant and product side of the chemical reaction. So what we're going to do is a couple of examples from this supplement, Keeping Track of Atoms. And right now, all we're going to do is indicate whether the equation is balanced or not. So if we look at this reaction here, we have ammonia, NH3, 4 of them, plus 6 nitrogen monoxides, producing the products nitrogen gas and water vapor. So here we have to be careful because there in this piece right here, there are 4 nitrogen atoms, but that's not it. There's a plus sign here, and right here there are 6 nitrogen atoms. So that gives me 10 total nitrogen atoms on the reactant side. This plus separates to add. This 4 means I have 4 separate NH3 molecules. So we would have an N bonded to an H, and an H, and we would have this 4 times. Remember, this is the chemical formula. The NH3 tells me what's bonded together, but then I would have that 4 times. So it would look like this, N with 3 H's. So if we have N with 3 H's, what happens is we end up with 4 N's, 1, 2, 3, 4. And then 6 NOs, you can picture that. We'd have 6 N's in that case, and 10 of them. So the H's, we would have 4 times 3 is 12. And the O's, they're only in one spot. And the O's, we have 6 O's. On the other side, we have 10 N's, and we have 12 H's, and we have 6 O's. So the number of atoms of each element, 10 N's, 10 N's, 12 H's, 12 H's, 6 O's, 6 O's, are the same. So we would say, yes, this equation is balanced. To have a balanced equation, you need to have the same number of atoms of each element on the reactant side and the product side. And then we say it's balanced. Right now, at this point, if they did not match, for instance, on this one, there's 1 Na, 1 Cl, and 2 Fs. Here we have 1 Na, 1 F, and 2 Cls. 1 Na on the reactant side, 1 Na on the product side, they match. But you cannot start a chemical equation with one Cl and end with two. That's impossible. You cannot start a chemical reaction with two Fs and end with only one. That's impossible. This equation is not balanced. This equation does not show what happens in real life. It does not show what actually takes place. So we would say that this is not balanced, and we would have to go fix it to show what actually takes place in real life. Our next piece of the video series, we will discuss how we make this, how we fix it to show what takes place in real life.